Hello and welcome to the Dance or Die extended presentation. My name is Raisin Snyder,
And I'm Joseph Blum.
and let's talk about our project.
So the idea behind our project was inspired by actually the first day of class, where we were shown pose compare, which isn't something either of us have really been exposed to before. Uh, and we both thought the technology was really cool, and we wanted to try to find a way to use it to do something like creative or interesting. Maybe it's been done before, probably, but we want to do something that we thought was fun and like at least novel to us. So we hit on the idea of doing dancing. Honestly, largely in part due to our cohort mate, Catherine, who's kind of an inspiration because she incorporates a lot of art and art forms into her robotics work.
Mhm.
So we wanted to try to do something a little similar for this class.
Yeah. So the approach for this was basically to get a model going to do these feature detections. So for that, we started with MediaPipe and Yellow 11 Nano. This was to do a comparison. We wanted to see what models work best, what models work fastest, and have some variety for what we were doing and testing out. Um, with those models, we had to do some normalization to compare the video streams, which we'll talk more about later. And then we used cosine similarity for a scoring metric, which will also be expanded on in future slides.
So the first of the models we used was YOLO, provided by Ultralytics. And YOLO is open source, so there's different ways you can get it, but Ultralytics is by far the most popular. YOLO is very modern, it's very configurable. There's a lot of different things YOLO can do in the same framework, which makes it very like flexible. And at least the Ultralytics version of YOLO is very easy to use, which is great. One of the things that was really helpful for our project is that YOLO comes in different sizes. So you can have a very like high capacity model that maybe runs slower, which is like the extra large, or you can have the fastest, leanest version of the model that might give you worse results. But if the results are good enough, then you get a lot of value from being able to like configure that size. And I think YOLO 11 at least comes in five sizes: nano, small, medium, large, and extra large. And for this project, we use nano, which works really, really well. And even that we can run it on our laptops. The one trade-off with the YOLO model is that it's built on the back of the existing like object detection model. So in some ways, it makes it a lot faster, but there is like a bit of a trade-off with that it's not like purpose-built to do pose detection.
Yeah, yeah.
So the other model we use is MediaPipe, which is a very classic tool for you doing pose detection. And while MediaPipe does work well, and I think the accuracy is noticeably better than YOLO 11 Nano, in our experience, at least on our laptops, it was much slower. And given how like dynamic and fast some of the movements are for our project, for tracking dancing or even for comparing dancing, where you might want to have multiple versions of the model running at once, it ended up being, well, you'll see how it ended up being, but it ended up being less valuable to us. Some other things to say about it is that besides being noticeably slower, the interface for working with MediaPipe and code is a little clunkier. There's a little like more abstracted away, but not in a way that's necessarily helpful. Um, but the detections are a little bit more valuable than the nano version of YOLO. And it's probably due in large part to the fact that MediaPipe is like a purpose-built model for doing pose detection, whereas YOLO is a little bit more dynamic or like flexible.
Yeah, so to work with these models and actually get valuable data out of them that we could use to, create this dancing game or, create this score metric for the game, we opted to use cosine similarity. So it's not the only metric for comparing poses. There's other things we could have done, like comparing joint angles, stuff like that. But ultimately, we cared about the orientation of the key points that the models were detecting. So cosine similarity really shines there in classifying and building those metrics, which we then fed into our scoring system.
Yeah, on the surface, it's not immediately obvious how we can use cosine similarity to compare two different poses. But something clever that you can do with a pose, which is really just a big collection of ordered points on an image, is if you can flatten it, so you put all the points into one big vector, uh, you can compare them like the way you would use any method to compare two vectors, like cosine similarity or Euclidean distance. But it's very important when doing this that when you flatten two different poses that they get flattened in the same way. So if the points get mixed up, your data will be garbage, and even into like your score that you get at the other end will be meaningless. So we had to do a little bit of data transformation to use some of these metrics and like to make cosine similarity like really work. Uh, but it was nothing too difficult.
Yeah, so and another thing we did to kind of optimize this method of testing both MediaPipe and YOLO was trying to do our best to write modular code. So ultimately, what we have is the core code written as one class that is the pose compare, which has both our or all of our image comparing methods. It has the dance comparing methods, and also like a side by side live dynamic comparison that is all inherited by the uh, other models.
Yeah.
Okay, so here is some results of our static image comparison. So this was kind of the foundation for what we were doing and where we started with training our um, where we started training our models and working on getting our metrics and scores to look proper. So you can't see it maybe because the uh, sharing thing is blocking it, but the score on the top is much lower because I'm very clearly at an incorrect position, whereas on the bottom, I have a much closer match, and thus the score is a lot closer to the 1.0 of being a perfect score.
Yeah, some of this example also illustrates really well is that with cosine similarity, it's really sensitive to orientation, which works really well for dance. So you can see a huge difference in these two images, whereas something like Euclidean distance will show a smaller distance. Uh, so like things that are orthogonal will be zero, and like fully opposite will be -1. Uh, so it lets us like compare the idea of two poses being like oriented the same way, which ends up working really, really well.
Yeah, so now we're gonna include some live static comparisons and demonstrate both the difference between the yellow models and the media pipe for how those work and calculate the scores.
So like we just saw, we can compare like one person's pose to like a still image that is unmoving, and that's really useful for like fine-tuning exactly how the math is working, making sure like normalization and our like score metric is working well. Something else we can do with our setup is we can also compare two people side by side in one image frame, and this starts to push MediaPipe a little farther because you're running like multiple versions of the model at once. YOLO still performs this quite well. Uh, and this is like a good setup to like build towards like the final implementation of our project, and as well as like a useful debugging tool because you can get a feel for like what accuracy really looks like with like one live model versus another.
Yeah, so now we're gonna have some live dynamic comparisons. Again, both the yellow and media pipe version, and now is when you really start to see, like Joe said, the performance issues that MediaPipe has that will only further be exacerbated in future demos.
Yeah, so then this brings us to the final version of our project, which has the full end-to-end pipeline involving, duck typing for either using MediaPipe or YOLO for all these functionalities. And we can also like do the final version of a comparison to a dynamic dance video for a user and give you a current score. This is also extended to track every detection in a frame for MediaPipe and YOLO, and that will expand upon the scores, even if the formatting is pretty bad, admittedly, and show different scores for each user in the frame. Uh, there are a couple drawbacks to our implementation for this, which is just representative of like it being a rougher version of the project, in that there's no tracking between detection sets. So if users swap places, their scores will typically swap.
Yes, yes. Or if, say, one user leaves the screen, the scores stay in the reformatted size rather than scaling back up based on the amount of users present on the screen.
Yeah, and so from here we'll show the full end to end of our project and like what we envisioned it being used for, to not only like learn a dance, but to also compete against someone else to learn that same dance.
Separated into, oh, and baby you left and sailed away alone, yeah, alone. And now you got me trapped up on this island where nowhere to get home. And I don't wanna go, I don't wanna go, I don't want it, no, I don't want it, no, I don't want to walk this earth if I gotta do it solo, solo.
C B C B I love C B.
So this mostly concludes our project. For some future work, things we want to implement are a better, improved visuals for our scoring system, as occasionally the colors can be hard to read, or the placement and size of the words can be difficult for users to read, especially if they're on a smaller screen. And there's also discussion of doing a graphical user interface. So at the moment, this is all run from the command line. You're editing, 2 or 3 lines in the code to choose your video, choose what, if you want to do image compare, dance compare, etc. Whereas with this user interface, you could do all that from one applet of sorts, and it would be a much more streamlined process for displaying it, showing it, and interacting with it.
Something else that would be valuable would also be to at least have some kind of idea of object detection to track one person versus another to keep better track of the score. Although that might be a bit of a stretch goal.
That's yeah. So
And that concludes our presentation.
thank you very much for watching. Have a great summer.